practice some multiplication problems together. I'll just wait for a second until everyone's ready to go. I see some people who still don't have their red notebook out and something to write with. Okay, you need your red notebook out, please. Okay, our first problem that we're going to solve today, we're going to use the distributive property. Let's put today's date at the top of the paper. Today's date is November 9th, 2021. Okay, and we're just going to label this page multiplication strategies. Okay, so multiplication strategies. Okay, so the first one that we want to use is called the distributive property. We have been using the distributive property. Okay, it is important that you label and put all of the steps that I'm including to keep your work neat and organized. Okay, so let's just say our first problem, go ahead and give me a factor that's 3 or 4 digits. You pick the factor, Landon.
5,953.
5,000 what?
153.
153 times, give me the next factor, please. Colin?
400.
Well, a 1-digit factor. 4. 5,153 times 4. So we know that we can use the properties of multiplication to help us solve this. First of all, the commutative property says that we can switch around our factors and still get the same product. So instead of putting 5,153, I'm going to have the 4 go first because I think that makes my distributive property a little less bulky. Okay, some people in the front need to make sure that they're with me and paying attention. Then the distributive property says that I can multiply the sum of the parts and get the same product as if I multiply it by the whole number. So we want to break this apart by place value because it makes it easier to multiply. Okay, so instead of doing 5,153, we're going to break it apart by place value. So that is the same as if I write it in expanded form. So who can tell me the expanded form for this whole number? Carter? 5,000. Thank you. Okay, so instead of doing 5,153, I'm doing 5,000 plus 100 plus 50 plus 3. So the distributive property says that I can distribute that 4 or I can multiply it by each one of these numbers. Okay, so underneath that, write each multiplication problem. So it's 4 times 5,000 plus 4 times 100 plus 4 times 50 plus 4 times 3. And now it's really easy. 4 times 5,000 is pretty easy to find. What is 4 times 5? 20. And then how many zeros do I need to add? 3, because I didn't really do 4 times 5. I did 4 times 5,000. So I have to, sometimes we might say annex those zeros and put them down here, but I just like to say add the zeros. 20,000 plus, what is 4 times 100? That should be pretty easy to do. 400 plus 4 times 50. So what is 4 times 5? 20. And how many zeros should I add? 1. And then finally, what is 4 times 3? 12. And so who remembers that term? What do we call these 4 numbers? There are what? Partial products. So let's just write that term out here to the side. These are our partial products. And in order to get our total product, or what this is equal to, I need to add together my partial products. Now, you may be able to do that in your head. 20,000 plus 400 is 20,400, plus another 200 is 20,600, plus another 12 is 20,612. If you can't do that in your head, that's fine. You are welcome to write out the partial products just like this and add them together. 20,612. Okay? That's the distributive property of multiplication. Now, I'm going to show you another method, and it's called an area model, or some people like to call it the box method. And it really uses the same strategy. Oh, brother. It never fails that the internet dies when I'm trying to do this. So I'm just going to keep talking until this internet comes back, and then we'll reconnect. So everyone go ahead and write down, give me a 3 or 4 digit factor. How about Cooper? 500? Give me something that doesn't have any zeros in it. 513 times, give me a 1 digit factor, Eloise. 9. So it's 513 times 9. So everyone should have that written across. 513 times 9. Okay, and then now I'm going to draw my area model, which is a long rectangle divided into 3 parts. Yep, it's a box method or area model. It's the same thing. Okay, I'll hold it up really quick. This is what you should have on your paper. 513 times 9. Area model or box method. They're the same. When someone says area model, that's what they're looking at. Okay? Now, I'm going to pause the video and reconnect. So, if you're watching from home, hold on.